Today's lesson involves using multiple rates of change to solve application problems. So unlike yesterday's lesson where we were looking at a single rate of change and integrating a rate of change to get an amount of change, today we are considering situations where there are multiple things going on, things going in and out, or increasing and decreasing, or perhaps two things increasing in a situation. So yesterday what we saw is that if we integrate a rate, then we get the change in amount at time A minus time B. So change in the amount of whatever is present between time A and time B. We could also write that same idea this way, that if I integrate a derivative function over an interval from A to B, then I get change in the original function. And we're talking about change in the y values over that same time interval. Okay, let's look at our first example. So here we have an example starting out with just a single rate of change that water is flowing into a tub at a rate of 6t plus 2 gallons per minute. So questions 1 and 2 and 3 we would have talked about yesterday. So take a moment and see what you can do with those three, and then I will go over the answers with you. So part 1 asks us to find the total amount of water pumped into the tank during the time between 0 and 3 minutes. So I learned yesterday that I can integrate my rate of change, so I can integrate r of t from time 0 to time 3, and that will give me the total amount of water. Again, using my calculator to get that value. I find out that that gives me 33 gallons have been pumped into the tank. The next question asks me to find the average rate at which the water is coming into the tank over the first 3 minutes. So I remember my average rate, and this is a little confusing because it sounds like I'm being asked to find an average rate of change. The only formula I have, though, is the rate of change formula. I don't have an amount formula to find an average rate of change. So in this case, I'm trying to find the average rate. Rate is the function I have. The 1 over b minus a formula works with the function that I have. And so I'm going to use that formula. So I want to use 1 over the first 3 minutes, so 3 minutes, integrating from 0 to 3. Of r of t dt. I already know the value of the integral. It's 33 divided by 3 gives me 11 gallons per minute. Notice why that would be again. If I integrate the integral from 0 to 3 of r of t, the units there are gallons. I know that from part A, or number 1 at the top there. And then dividing by 1 divided by 3 minutes puts me back at gallons per minute. So on average, 11 gallons per minute coming in. The next question tells me if there were 100 gallons of water in the tank at time 0. So I have an original amount here. This is an amount. And it's the amount at time t equals 0. How much water is there at the end of 3 minutes? Well, that would be the original amount that I had, plus the total amount that came in, the increase in water in the tank, and that gives me the overall total of water in the tank. Now if I read question 4, something different has happened here. Now suppose the tub drain is open as well. Water is flowing out of the tub at the same time it's coming in. So I have two different rates of change going on there that's affecting the amount of water in the tub overall. Then I still know there's 100 gallons of water in the tank at time 0. How much water is there at the end of 3 minutes? So now I have to figure out, this didn't change. The amount I had to start with didn't change. But my rate of change is being affected two ways. I have water coming in at a particular rate of 6t plus 2, and I have water going out at a particular rate, and that rate is 0.5 gallons per minute. It's just the constant, so it's going out at a constant rate. So then if I wanted to figure out how much water is there at the end of 3 minutes, I know that I need to figure out, okay, well, how much has this affected? What's been the overall effect of water in the tank, since some's coming in and some is going out? So I'm going to take my original amount of water. To that, I'm going to add the water that's coming in, and I have to integrate R of t. I've already done that actually, but I'm going to write it here again. Because R of t is a rate, so I have to integrate it in order to be finding the amount of water. Then I have to consider water going out, so I also need the total amount of water going out. Again, 0.5 is a rate at which the water is going out, so I need to integrate it in order to get back to an overall amount of water in the tank from 0 to 3. So I did not integrate 100. It was already an amount of water, 100 gallons of water. I did integrate the in rate so that then I can figure out the total amount of water that came in. I did integrate the out rate, again trying to figure out the overall amount of water that's going out. So I'm just going to enter all of that into my calculator. And I end up with 131.5 gallons. Okay. Then the final question here, is the water level rising or falling at t is 3 minutes? So I have to think about, this question is not as explicit as the ones before, where it was really clear whether I was being asked about an amount of water or a rate of change. In this case, I am being asked about a rate of change. The words rising or falling give me that information. So I'm being asked at what rate is the water changing. So I need to consider in rate minus out rate. Not the integrals, because that would just be the overall amount. And I need to know at exactly t is 3 minutes, not over any interval of time, but right there at 3 minutes, if I could just peek into the tub right at that minute. So my in rate is 6t plus 2. My out rate is 0.5. I'm trying to figure out what's going on at t is 3. So at t is 3, I would have 6 times 3, 18, plus 2 is 20. That's my rate in. Minus 0.5, that's my rate out. So the overall rate of change at t is 3 is 15.5 gallons per, that's not right, is 19.5 gallons per minute. So the rate of water, the water level is rising because my overall rate of change is positive. The water is coming in faster than it's going out. This is just a discussion about rates of change. We may have things coming into or going out in a lot of different situations. For example, the water in the tub, particular medicine, but then the body is absorbing the medicine or deleting the medicine. We talked earlier about sand on a beach, that there's beach erosion, so the ocean takes the sand away, but people like their beach properties, and so the government pumps sand back onto the beach. So we have both of those things going on at the same time. Of course, it's possible to have situations where it's not an in and an out, but two things coming in or two things going out, but it's more typical to see in and out, and I usually call these in and out problems. Here's another similar problem, except there's more information given to us in the setup of the problem. I see that I have 125 gallons of heating oil at time 0. So that's given to me. I have a time interval given to me there between t is 0 and t is 12, and heating oil is pumped into the tank at a rate of, and so there's my N rate. During the same time interval, heating oil is being removed from the tank at a rate of. So here is my out rate. So looking at the first question, how many gallons of heating oil are pumped into the tank during the time interval 0 to 12? So this is only asking me to consider how much comes in, not how much comes out or how much there is overall. And so I can find that by integrating. I want to do the full 12 hours, and I want to do this function that's called h of t dt. Using my calculator to evaluate that integral, I find that the total amount of heating oil in gallons that has come in over the 12-hour period is 70.571 gallons, again rounding to 3 decimal places. Is the level of heating oil rising or falling? So that's a rate of change question, and I notice that it's just at a particular time, not over an interval of time. So I need to consider the overall rate of change of the heating oil. So that's my N rate minus my out rate. No need to integrate here because I'm just considering rates of change. So that's h of t at t is 6, so I can call that h of 6, subtract the out at 6 hours is exactly the same as it is all the time. I have a constant out rate. So I need to then consider h of 6, and again, since my equation is in y1, I'm just going to do y1 of 6. I might get to y1. That turns out to be 5.395. Subtract 6.12. That's obviously negative. So that means that the level of heating oil is falling because the overall rate of change is negative. Or you could say because the rate in is less than the rate out. Either would be okay. Part C, how many gallons of heating oil are in the tank? Gallons are in the tank at T is 12. So that's an amount question. I need to then kind of scan through for what I know about the amount of heating oil. And I know that there was 125 gallons to start with. And then I have to consider how much has come in and how much has gone out over the 12-hour period. I'm going to integrate to figure out how much has come in because my N is a rate function. So I need to integrate from 0 to 12 of h of t dt. Then I need to consider how much has gone out. Again, I need to figure out the amount that's gone out. So I need to integrate my rate function to figure out the amount that's gone out. And what I notice then, just doing a little calculations here, I find that there's now 122.131 gallons in the tank. Part D asks me just to formalize really what I did in Part C, write an expression that would find the amount, the level of heating oil, so really the amount of heating oil in the tank at any time t, not just at time 12, And so I can just model it after what I did in Part C. Just introducing a variable to represent the any time in the future. And there I have my overall expression. In this last slide, I want you to complete this and bring it in tomorrow for kind of the homework or reading quiz assignment. So just to make sure that you've understood what the lesson has been about, that you don't have any questions about these. So answer these 5, and then bring it in tomorrow, and that's where we'll start our discussion of this lesson.